All right, so we're going to go through some examples from Chapter 6. I've picked out some problems from the study guide. Unfortunately, the problems in the book problems were not really equal in their content from the study guide problems. So what I've had to do is I've taken the study guide problems and I've changed them a little bit. So I'm not going through exactly the same problems, but they're going to be close enough that you should be able to get an idea of how to proceed and go ahead and solve the ones from the study guide. So the first one we're going to look at is based on problem number 77. And this says a sketch of a manufactured part is given below the drawing. Okay, sketch the planes of a datum reference frame in all of the views of the manufactured part. Label each of the datum planes that make up the datum reference frame and note the number of points of contact required with the feature surface. Complete the sketch based on a feature control frame that references datum A primary, B secondary, and C tertiary. Okay, so here is the drawing, right? And so from the drawing, the designer has labeled the bottom surface here as A, the back surface on the left as datum B, and the surface on the right as datum C. So then when we go to the manufactured part, and that's why these edges are, you know, kind of rough, because they're meant to simulate a manufactured part that is imperfect, right? Remember, the drawing is perfect, the manufactured part is imperfect. Now we want to identify where those datum planes, the planes of the datum reference, are going to lie. So first of all, what is the datum reference plane? So the datum reference plane in this example is A primary, B secondary, and C tertiary. Okay, all of these datums, A, B, and C, all of these datums are non-size features. So none of them are features of size. So we have no ability to put any kind of material modifiers in here. These are all just going to be your straightforward datum plane A, B, and C, primary, secondary, and tertiary. Okay, so moving here, so the bottom surface then is A, and I can see the bottom surface here. And the way I'm going to call this out is I'm going to draw my surface in there, right? And then I'll just kind of put some hatching in there. And that is going to be A. Okay. A, in this case, because it's primary, will be made up of 3 points. Right? Primary is always 3 points. We would see A in this view as well. Right? Because that is also the same surface. All right, B is this back surface here, and where do we see B? Well, we see B here and here. So I can do the same thing, some hatching here. This will be B. B, because it's the secondary, will be made up of 2 points. All right, and then B is also going to be here. We can see B there. And finally, C is this surface on the right-hand side. Now, we see this surface over here. So I'll do the same hatching. C. C is the tertiary and is always made up of a single point. Okay. Now C in the other views is going to be up here. So there's C. Okay. So our datum reference frame, is A, B, and C, and we can see that here. Okay. So that's problem 77. All right. Make sure in all of these application problems, and in fact all the problems in the book and the application problems from the study guide, there are very, very good examples in your textbook. Okay, so you really to really have a good chance of doing the application problems correctly, please reference the textbook. Make sure you go through those example problems in the textbook. And what I mean by example problems is the figures in the chapter. Okay, the figures in the chapter are usually very, very close to what you're being asked to do in the application problems. Okay, so that's problem 77. All right. Now let's move on to the next one that I want to do, which is problem number 80. Okay, or one very similar to problem number 80. Okay. So here we're doing datum targets. Okay, and problem number 80 says to show the datum target points on the given part, and here's my given part. Okay. Use a number of targets that permit datum references in the order of precedence shown in the given drawing. Label all targets, show the basic dimensions to define the target locations, and dimension values may be estimated, right? So we're just going to put in some numbers. It really doesn't matter. The numbers don't matter. Okay. So again, here's where our drawing is, or at least the partially completed drawing, and we know that this surface on the bottom here, right? This is two views, right? Top view and a right side view. This bottom surface here is the primary datum. The secondary datum is going to be kind of both of these surfaces together. And the tertiary datum is going to be on the left-hand side. Okay. So on the drawing then, let's finish the drawing. That's really what we're doing here. Okay. So here's the drawing, just enlarged and without these words in it. So we're still working on the drawing. And now we have to identify the datum targets. Okay, so let's start with the primary datum. Okay, so the primary datum, let me put just some notes up here. The primary datum is going to be composed of 3 target points, right? Because 3 points define a plane. And so we need 3 points to define the primary plane. All of these, by the way, are non-size features. So again, we're not talking about datum features of size. Okay, so we need 3 targets. All right. We're talking about this surface here, or the underside here. In general, it would be much better if we balance the point. You can think of the 3 fingers here as the 3 points that we're going to balance the part on. It would be better to balance this, and here I'll use this pad of paper, with a spaced out 3 target points. So rather than put them close together like this, where there's some, there could be some unsteadiness, we would want to space them out as much as possible so that we have a part as stable as possible. Okay? So then I'm going to space out my 3 points, and again, this is somewhat arbitrary, but I'm going to put 1 point here, and we label the point with an X. I'm going to put another point here, and I'm going to put another point here. Okay? So those are my 3 target points. Now, I need to call out these 3 points, and we call out a datum target with a line and a circle with a marker in it. Okay? So I'm going to call out this point, and this point is going to be, we'll call this A. So this is going to be A1. Okay? This point over here is A2, and this point over here is going to be A3. Okay? Now, knowing orthographic projection like you do, you should understand that we're talking about this surface. And in fact, let me label that surface because we need to label it as well. This is datum plane A. This surface in this view is underneath. So in order to indicate that our datum targets are under this visible surface in this orthographic projection, I need to connect the target balloon with a broken line. Okay? Okay, so with a broken line. All right, so let me just add some notes up here. So 3 points. Identify the plane, or let me not call it the plane. That's too ambiguous. Identify the datum. Right, that's what we did right there. We identified the datum. Okay. Then we need to locate the targets. And that's what we have here. And then we need to use basic dimensions to locate the targets. All right. Now, how do we use the basic dimensions? Well, we're going to locate these datum targets with basic dimensions to the other datum features. Okay, so this is the secondary one. So let's go ahead and put this in here. Now I'm going to connect this with an extension line here, and then I'll put that right there. And then C is up here. Like so. Okay. So I have my A, B, and C based on this. A, primary. B, secondary. C, tertiary. So that means that my datum reference frame is going to be A, B, and C. Right? Again, non-size features, so there's no RMB, MMB, or LMB. Okay. And now I need to locate these, because right now they're just X's on the bottom surface, but I don't know where they are. Okay. So let's locate them from datum B. So I'm trying to find my room here. So let's do this. And this is where the instruction said that we can I'm just going to put XX because the numbers don't matter. And I'm going to connect this through here. Actually, no, I'm not going to put that through there. Forget that. Ignore that. That's just going to confuse the issue here. This one. All right, and this one. Okay. So from B, from datum feature B, datum plane B, I'm going to go this height, basic dimension, this far to find this, and here and here. Now I need to also do it from C. Again, basic dimensions from C. And just because of space, I think I'll go here. Okay. So now, what do we have? We have the datum identified. All right, in this view. In this view, I've located the targets with an X. I've indicated that they're on the far side by using the broken lines. I've called them out A1, A2, A3, so we have 3 points. And then I've located them relative to the other datum planes, other datum features, with basic dimensions. All right, and so now we're just going to repeat that. All right, so let's go to the secondary. Now the secondary is going to be 2 points. Right? Remember, Primary is 3 points, secondary is 2 points. So we're going to do everything that we did here. Now, just to be a little bit, well, here, we'll put 1 point here. And we'll put 1 point right in the middle of this surface right here. Okay. Now, I purposely put this X right on this line, extension line, because then I can make use of this basic dimension from C. So I'm just kind of doubling up with that. This is on a visible surface. So this is just going to be B2. This is going to be B1, again, a visible surface. In this view, these X's, these points, I want to make sure that they're right in the middle. Okay. And this will, now interestingly, in this view, I would actually see B1 and B2 lined up with each other. Right? So B1, B2. Right? Because in this view, both X's just kind of line up. All right, I'm still missing some basic dimensions. I have one basic dimension here that I'm kind of stealing from my other one. I need a basic dimension from A. Remember, we have to locate each one back to the other datum references. So I can use a basic dimension there. And then I need to locate this one. Now, this one's a little bit tricky. We'll put that right there. Okay. And then that's it. Okay. We don't need to locate them from B because they are B. We need to locate them from A and C. We locate the A datum targets from B and C. B, we locate it from A and C. And C, we're going to locate them from A and B. Okay? So there's our secondary. And now let's go to our tertiary. And our tertiary, right, if 3 was our primary, 2 points are our secondary, our tertiary is going to be 1 point. So we only need 1 point to find C. And I want to balance it, so I'm going to put it right in the middle here. Okay. Let's see, we're running out of room here, so I'm going to put, this is on the visible surface right there, so I'll call that C1. All right. In this view, I want to put it right in the middle of this surface, so let me erase this a little bit. I'm going to put it right, whoops. I'm going to put it right there. Okay. Now, however, though, in this view, this X is actually on the back side. So, again, I want to remember this is C1. Okay. And so I've identified the datum, right? It's C. I've located the targets, and I should put in here in all views. Right? So in all views, C1 is here, C1 is here. And then I want to use basic dimensions to locate it relative to the other datums. So let's see, this is going to be kind of tight here, so I'm going to change this around a little bit. I apologize for the space restriction. So there is locating it from, oh no, I want to locate it from B. That's not B. Sorry. I located it from there. So B is this surface right here. So I want to... well, actually, I could do that. Why could I do that? That's a good question. I'm going to put that back in there. Why is that okay? Okay, well, a couple things about basic dimensions. Basic dimensions are perfect dimensions, theoretically perfect dimensions. They add perfectly. Okay, there's no round off error. There's no tolerance accumulation with basic dimensions. You're perfect, adding and subtracting, all that stuff. So what I want to do is I want to locate this datum target C1 relative to B right here. Well, I have this dimension, this basic dimension from B to this X, to this datum target. And then I have a basic dimension from this datum target to this datum target. And now I've put a basic dimension from this datum target to C1. So in other words, if I replace these with numbers, let's just replace these with numbers just so I can show you. Let's say this is 10 millimeters. Let's say this is 20 millimeters. And let's say this is 10 millimeters. Okay. Can I get to here from this surface? Yes, it would be 10 plus 20 is 30 minus 10 is 20. Okay. So I don't have to do anything. You also can't technically speaking, you can't over dimension with basic dimensions because they're perfect dimensions. Okay. All right. And the last one here, we need to locate A. And because I want this to be in the same level, I'll just connect this with an extension line, and then that dimension is there. Okay, so this one is probably the most work of the whole group, but it's real important to understand each stage of what's going on, okay? What we're doing is we're identifying, first of all, we're calling out the datum reference frame A, B, and C on this part. A is here, the bottom surface. B is this front surface, and C is this back surface on the left-hand side. But because we could presume that this is a cast part, maybe it has, rough edges, rough surfaces, we can't, or it's impractical to use, to expect this to sit flat on a table. So we want to measure it. And we want to find these datums, but because of its imperfections, we need to call out datum plane A with 3 points and space them out, right? So 3 points define datum plane A. Right. Then we're going to locate datum plane B with 2 points. And you can think of datum plane B here as 2 points. We're going to put it up against those 2 points. And finally, datum plane C is going to be here. Okay? All right. So I think that's the drawing, the problems that I want to work out for the first part of this. I have a couple more problems that I want to work out, but I'll do that in a second video.